Assalamualaikum warahmatullahi wabarakatuh and hi to all of the panels. I am Nurul Fatihah binti Ismadi, a final year student, Applied Chemistry. Today, I would like to present my final year project entitled A Review on the Effect of Concentration, Temperature, and Reaction Time of Coal Desulfurization by Potassium Tert-Butoxide, supervised by Madam Syarifah Nursyimi Azlina binti Syed Ismail. Firstly, let's begin my presentation with Table of Contents. It contains introduction, literature review, conclusion, and recommendation. Describing about background of study. So, firstly, what is coal? Coal, with a large volume of carbon combustible black or dark brown stone consisting of carbonated growth material found in the basement and serve as fuel. Coal, also known as complex heterogeneous that varies chemically and physically. Coal is made up of organic and inorganic compounds. The organic part of coal consists of carbon, oxygen, hydrogen, sulfur, and nitrogen. There are four major types of range of coal, which are anthracite, bituminous, subbituminous, and lignite. According to the Grammar List et al. 2016, bituminous coal is widely used due to the percentage of carbon content, which is from 50 to 80%, and could be utilized or manipulated. What is the use of coal? Coal is the main source to generate electricity. When high demand consumption, burning coal is done on a massive scale, which will cause production of sulfur dioxide gas. One of the most problems faced by the coal separation industry is the content of sulfur in coal cannot be completely removed and will cause air pollution result from combustion of coal, which produce sulfur dioxide gas released into the air and affects human health. Desulfurization of coal is very important before burning activities and utilizing on it, such as to generate electricity. There are some methods carried out to eliminate organic and inorganic sulfur in coal, for example, by physical, chemical, and biological desulfurization. Chemical desulfurization is considered suitable for coal desulfurization due to short treatment period, obtain higher desulfurization efficiency of inorganic sulfur, and environmentally friendly. Chemical desulfurization can remove inorganic sulfur in coal effectively. Nevertheless, limitation of chemical desulfurization to remove sulfur from coal that is due to the certain organic sulfur still exists in the coal matrix after treatment process. The structure found in carbon and natural characteristic of coal are destroyed. The significant desulfurization of coal to community is to generate coal-fired power plant with low electricity tariff rates. Then it can give early education to the community about the danger of sulfur dioxide gas. This finding will provide the necessary guideline data for future research and related studies. Other than that, coal separation industry or company will be use this method in order to use it in their daily processes. The main objectives of research are to review the desulfurization of coal by using potassium tert-butoxide and to examine the effect of different concentration, temperature, and reaction time on desulfurization of coal. What is desulfurization? Desulfurization is sulfur removal from coal or flue gas. Sulfur content is divided into two categories, which are organic and inorganic sulfur. The percentage of sulfur in coal can be classified by three categories, which firstly is low sulfur coal by less than 1%. Secondly is medium sulfur coal, which is from 1 to 3%. And lastly is high sulfur coal from above 3%. As mentioned by Tang et al. 2020, organic sulfur consists of thiol, thiophene, thioether, sulfoside, and sulfate. According to Zia and Z 2017, one of the inorganic sulfur is pyrite. There are three methods for desulfurization of coal, which are biological, physical, and chemical desulfurization. There are limitations with biological and physical desulfurization. Biological desulfurization can remove organic and inorganic sulfur, but the long processing time and the problem of slow microbial growth still make it difficult to use in industrial desulfurization. For physical desulfurization, physical methods are ineffective and intensive of time can be implemented only on the bench scale. So, what is chemical desulfurization? Chemical desulfurization is a process removal of sulfur from coal by using chemical reagent. Chemical desulfurization, also known as chemical leaching. There are two types of chemical leaching, which are acid and alkaline. Hence, alkaline leaching was selected to review in this study. Alkaline leaching process is the method of breaking down soluble minerals in coal by using alkaline solvent. Reductive desulfurization is commonly known as removal of sulfur assisted by reducing agent. There are two types of additive which are oxidation additive and reduction additive. Potassium Tert-Butoxide is known as reducing agent and was chosen for this study to see if it could desulfurize organic sulfur deeply. There are three factors or parameters that have been discussed by the previous researcher for removing inorganic and organic sulfur from coal. So, in this research, further analysis will be investigated on the effects of different concentration, temperature, and reaction time. Firstly is concentration of chemicals. As mentioned by Tang et al. 2018, when the concentration increased from 3 to 15 molar, the removal of sulfur from coal rapidly increased from 9 to 55%. As stated by Tang et al. 2018, the concentration of potassium Tert-Butoxide is approximately from 7.5 to 22.5 molar, achieving total sulfur reduction coal increase, which is 95.7% and 87.2% respectively. As reported by Tang et al. 2018, removal of organic sulfur of Xinyu and Guzian coal were 65.8 and 64.2% accordingly with 15 molar of concentration. Next, pyritic sulfur was removed about more than 80%. Hence, by using potassium Tert-Butoxide as reductive reagent, the process was effective to remove both organic and inorganic sulfur. Next is temperature. As stated by Tang et al. 2018, as the processing temperature increased from 155 to 185 degrees Celsius, the percentage of total sulfur reduction in coal will increase, which is 47.6 and 34.3%. When prolonging the processing temperature from 185 to 215 degrees Celsius, reduction of total sulfur also increased by 46.8 and 37.8%. According to Tang et al. 2018, when the optimum temperature at 185 degrees Celsius, the removal degree of organic sulfur increased approximately 55%. Lastly is reaction time. When the reaction time was between 0 and 16 minutes, the percentage of sulfur ether and thiophene in sample reduced significantly, dropping from 0.57 and 1.35 to 0.20 and 0.65% accordingly. Then, between 20 and 16 minutes of desulfurization process, the amount of sulfonate and sulfonic ester raised from 0.02% to 0.23%, and then changed a little since time passed. According to Tang et al. 2020, reducing the reaction time, which is 18 minutes, will be resulted higher in organic sulfur desulfurization performance compared to biological desulfurization method. It was found that after treatment for 240 minutes, more than 85% of sulfur ether and thiophene in Xinyu raw coal were removed, indicating that the heterocyclic sulfur could be removed from coal to a high degree. Tang et al. 2018. This study has revised on the desulfurization of coal, especially by using potassium Tert-Butoxide. Chemical desulfurization is chosen to review in this research paper due to flexible, easy, and take a short reaction time and could remove both organic and inorganic sulfur effectively compared to physical and biological methods. Sulfur content can be divided into two categories, which are organic and inorganic sulfur. Organic sulfur is difficult to remove within the coal due to being tightly bound in the organic coal, while inorganic sulfur is more easily to remove from coal by using leaching process. There are three parameters have been examined on the desulfurization of coal, which are different temperature, concentration, and processing time. Hence, from the review, it was found that the optimum condition to eliminate sulfur in coal is 15 molar for concentration, 250 degrees Celsius for temperature, and 18 minutes for reaction time. Xinyu coal can reduce the content of organic sulfur and sulfur by 90.5%, 65.8%, and 66.7%, while for Guzian coal is 85%, 64.2%, and 68.9%. Thiophene sulfur found on the surface of coal can be removed without effectively destroying the carbon shell of coal. For the recommendation, more studies regarding coal desulfurization by using alkali chemicals, specifically by using potassium Tert-Butoxide, need to be done. Next, do a modification on both parameters, which are time and temperature. The parameter should be started exactly with higher value due to investigate the possibility more percentage of organic sulfur will be removed from coal sample by using potassium Tert-Butoxide. Lastly, investigate the effect of coal particle size along with the three parameters above on desulfurization of coal due to determine whether if the particle size of coal is smaller, it will increase the surface area and could be increase the percentage of removal of organic sulfur in coal.